First, you start with 60 grams of potassium nitrate and put it into a pot. You then grab 40 grams of sugar and put it in the pot along with the potassium nitrate. You then turn the burner on low and you stir it until it becomes a peanut buttery substance. Then we added several different kinds of dyes. Unfortunately, none of them worked, and we'll explain why later in the video. Once we had all that stirred in, we transferred it into an aluminum can.
We then used fuses that we had made ourselves out of potassium nitrate and sugar. We stuck them firmly into the mixture, made sure they were secure and they wouldn't come loose when we tried to light them later. We then took the can outside, away from anything else, lit it, and stood back to watch. Potassium nitrate is an oxidizer. The sugar is the compound being oxidized. Just mixing the two together does not cause the smoke. The mixture must be ignited. The reason for the smoke is that only part of the fuel, the sugar, is oxidized all the way to carbon dioxide and water. Some of the sugar is only partially oxidized and will be seen as a suspension of soot or carbon in the air. This is the smoke. If you add dye to your mixture, the color will burn but not color any of the smoke. It won't blow up in your face either, it'll just make white smoke. Colored smoke bombs cannot be made with potassium nitrate, no matter what you read on the web or see on YouTube. Potassium nitrate burns way too hot. Even if you were able to get the smoke dyes, the potassium nitrate would just decompose the smoke dye, creating ugly gray smoke.
Swimming pool chlorine and brake fluid are household items. When you combine these chemicals, you create a reaction consisting of an oxidizing agent, calcium hypochlorite, which is swimming pool chlorine, and a fuel source, polyethylene glycol-based brake fluid. When the fuel rapidly oxidizes in the presence of the oxidizing agent, the mixture spontaneously combusts, resulting in a fireball. We attempted this experiment several times, but they resulted in nothing but lots of smoke. Finally, after almost a dozen failures, the reaction worked. Our hypothesis for our many failures is that we used the wrong kind of brake fluid, .3, instead of .4, or that the brake fluid was too old.
In this experiment, we placed small piles of lithium chloride, strontium chloride, copper chloride, barium chloride, and Epsom salt in a row on a pan. We poured alcohol over the salts, which was used as fuel for the fire and helped the salts to burn. When the salts are lit, the ions in the salts react to form a wavelength of light that we see as different colors. Many ions of metals and nonmetals turn flame different colors. Atoms move to an excited or unstable state when heated. When they return to their stable state, the excess energy releases in the form of light of a certain wavelength, which represents the color we see in the fire. One ion coincides with a certain wavelength of a color. The color emitted by larger atoms is lower in energy, while color emitted by smaller atoms is higher in energy. For example, red has a long wavelength of less energy, and as the energy increases, the wavelength shortens, and we see colors like blue and violet.
Our goal was to demonstrate explosive polymerization. We combined paranitroaniline and sulfuric acid, but because we couldn't find the proper amounts, we had to experiment. In our first attempt, we combined half a teaspoon of paranitroaniline and a few drops of sulfuric acid in a glass coffee mug. The reaction took place, but because we didn't use enough of either ingredient and applied too much heat, it did not react like we had expected and the mug broke. In our second attempt, we added more of each ingredient. This reaction turned out better than the first one, however, it did not form a tower of foam like we were hoping. In the third attempt, we used the same amount of paranitroaniline, but used more sulfuric acid. This time, we used a jar lid. The reaction spilled over the side before it could properly go off. In the fourth and final attempt, we used approximately the same amounts of paranitroaniline and sulfuric acid as the previous attempt. This time, we applied the heat very slowly in hopes of getting a better reaction. The results were very similar to our first attempt. In this experiment, paranitroaniline was combined with sulfuric acid. The sulfuric acid broke down the p-nitroaniline into fragments. The fragments combined to form long chains of molecules called polymers. These polymers acted like a mesh. When the mixture was heated, it gave off water vapor, carbon dioxide, sulfur dioxide, and other gases. If this experiment would have worked, these gases would have gotten caught in the mesh and foamed up.
So what is actually going on? Sugar is an organic substance composed of carbon, hydrogen, and oxygen. When ignited, it burns slowly in the presence of oxygen, but the reaction can be accelerated by adding an oxidant. In the case of rocket fuel, potassium nitrate is added as the oxidant. The potassium nitrate and the sugar react to form gases, namely carbon dioxide and water vapor. The expansion during the reaction of these elements creates a thrust that is used to power the rocket. The ratio of sugar to oxidant determines the amount of thrust, which is how rockets are propelled. This ratio is finely tuned so that the reaction creates the perfect amount of thrust. Disclaimer: in our video, we are not trying to have the rocket lift off. Our goal is to successfully create and burn rocket fuel.
Let's see if it's sizzling. Yeah. This is a chemical experiment observing the reaction between aluminum and iodine. Aluminum is a metal and iodine is a purplish-gray nonmetal. They chemically combine to form aluminum iodide. The reaction between aluminum and iodine is very slow, so water is used as a catalyst as aluminum iodide reacts strongly with water. This reaction is an exothermic redox reaction that produces a lot of heat so that iodine sublimates and forms a purple vapor. So windy. Okay, can we stop it? Stop it at 2 minutes.
Tannerite is a fun explosive that is really easy to make and is a fun thing to use if you are target practicing. You will need the following items. And for this experiment, we're using 1,000 grams of ammonium nitrate and 50 grams of aluminum powder. As long as you keep the ratio of 95% of your mix being ammonium nitrate and 5% being aluminum powder, then you should be fine. Any amount should work. You also need a rifle and bullets. and a peanut butter jar or something with a lid that you can screw on to keep the gas that is produced when you mix the two ammonium nitrate and aluminum powder together. A chemical explosion has to have these fundamental components: a fuel and an oxidizer. In this case, the aluminum powder is the fuel and the ammonium nitrate is the oxidizer. What the oxidizer does, it gives up oxygen for the fuel so it can ignite. Now when you mix these two things together, you make a gas that is explosive, and the way to set this gas off is to have a shock wave, hence a speeding bullet.
You ready?
Hold on.
About to go boom.
Did you warn your neighbors? What neighbors?
Does your mom know we're doing this?
Yeah, mom knows we're doing
Okay.
Alright, y'all ready?
Yeah. Let's go. Oh!
Let me
yeah.
start.